Understanding the winner logic in Tic Tac Toe, Get Winner. Tic Tac Toe is one of the simplest yet most captivating games, known for its straightforward rules but deep strategy. The primary goal of the game is for a player to align three of their marks, either X or O, in a straight line horizontally, vertically, or diagonally. This makes the logic of determining the winner the central pillar of the gameplay experience. Implementing a Get Winner function in a tic-tac-toe game in Flutter requires a firm understanding of both the game rules and how to handle game state updates in a user interface that reacts dynamically to the player's moves. In a traditional 3x3 grid, the winning conditions are straightforward. There are 8 possible winning lines. These consist of 3 horizontal rows, 3 vertical columns, and 2 diagonals. For each of these lines, the game must check if all 3 positions are filled with the same player's mark, either X or O. If any of the lines meet this condition, the game should immediately declare that player the winner. Once a player wins, no further moves should be allowed, ensuring that the game has a clear and unambiguous result. The real challenge of determining the winner lies in efficiently checking these winning conditions after every move. For every move, the game must evaluate all 8 potential winning lines, comparing the 3 marks in each to see if they are identical. For example, if the first row contains the marks at positions 0, 0, 0, 1, and 0, 2, the game must check if they are all the same. If they are, the player who placed those marks is the winner, and the game halts. The same check is performed for all rows, columns, and diagonals, ensuring that no possible winner is overlooked. To implement this logic effectively, the board is often represented as a 2D array or list in Flutter. This array will contain 9 elements, representing each of the cells in the tic-tac-toe grid. These elements are typically initialized to null or an empty value to represent empty spaces. As the game progresses, the elements in this array will be filled with either X or O. After every move, the game will check the current state of the array to see if any of the rows, columns, or diagonals meet the winning conditions. While the basic logic for determining the winner is simple, comparing the 3 marks in a line, several edge cases must be handled. For instance, the game must ensure that the player has actually filled all 3 positions of a line before declaring them the winner. If a player attempts to make a move in an already filled spot, or if there's an incomplete line, the game should prevent this and request a valid move. Similarly, the winner checking function must also ensure that after a winner is found, the game stops further evaluation. This prevents any unnecessary checks after the game has concluded. An important consideration in the winner logic is managing the state of the game board. The game needs to evaluate whether a player has won after each turn, but it also needs to check for draw situations where the grid is completely filled without any player aligning 3 marks. Once the game recognizes a winner or a draw, it should immediately end, and the UI should reflect the results, notifying the player of the outcome. Handling game over scenarios seamlessly is essential for a positive user experience. Additionally, it is helpful to design the game so that if the players wish, they can quickly restart the game for a new round. A final aspect of winner detection in tic-tac-toe is the visual and user experience design. After detecting a winner, it is essential to provide immediate feedback to the players. This feedback could be as simple as a message displaying player X wins, or player O wins, but the game could also visually highlight the winning combination. This can involve changing the background color of the winning row, column, or diagonal to make the victory more noticeable and satisfying for the player. Moreover, ensuring that the game provides a clear call to action, such as a button to restart or exit the game, can improve the flow and engagement for users. Implementing the winner check in Flutter, how the game logic works. When building a tic-tac-toe game in Flutter, the implementation of the winner checking function is fundamental to ensuring that the game runs smoothly. The goal of this function is to evaluate the state of the game board after each move, check all possible winning combinations, and return a result indicating whether a player has won, or if the game is still ongoing. This process involves interacting with Flutter's reactive framework to update the user interface based on the current game state, which is updated as players take turns. In a typical Flutter implementation, the board is represented by a 3x3 matrix. This matrix could be constructed using a 2D list or a simple one-dimensional list with 9 elements. Each element of the list corresponds to a cell on the board and holds a value representing the current state of that cell, either X, O, or null if it's empty. Flutter's reactive state management system allows the game to check the board state each time a player makes a move and updates the UI to reflect this. After each move, the first task of the winner checking function is to evaluate the state of the board to see if any of the 8 possible winning lines contain 3 identical marks. This evaluation is essential after every player's move, as the board state is continually changing. The function first checks the rows, one by one, comparing the values of the cells in each row. For example, in the first row, the function checks the cells at positions 0, 0, 0, 1, and 0, 2. If all 3 cells contain the same mark, either X or O, the game declares the player associated with that mark as the winner. The function then repeats this process for the 3 columns of the grid. It checks if all the cells in each column contain the same value, ensuring that the player has aligned their marks vertically. Finally, the function evaluates the 2 diagonals, one running from the top left to the bottom right of the grid, and the other from the top right to the bottom left. If any of these diagonals contains 3 identical marks, a winner is declared. Once the winner checking function detects a winner, it is essential to stop further checks and update the game state. The game should notify the players that the game is over, and no further moves should be allowed. To implement this, the winner checking function must be designed to break out of any further checks once a winner is found. If no winner is found after evaluating all possible lines, the game should continue and allow the next player to take their turn. Managing the game state efficiently is critical when implementing the winner checking logic. The game should maintain variables or flags that track whether a player has won or if the game is a draw. Once the winner checking function detects a win or a draw, these flags should be updated accordingly, and the game should cease further moves. The UI should then reflect the game's outcome, displaying an appropriate message to the players and giving them the option to restart the game or end the session. In Flutter, updating the UI in response to game state changes is straightforward thanks to the framework's built-in state management capabilities. When a move is made, the game board is updated, and the winner checking function is invoked. Based on the result, the UI is refreshed to either highlight the winning combination or display a message announcing the draw. The ability to trigger these updates in real time is one of the key strengths of using Flutter for game development. Another important consideration is handling edge cases. For instance, if the game ends in a draw, the game should check whether all cells on the board have been filled. This check is necessary because the game can end in a draw only when all spaces are filled, and no player has won. Once the game determines that all cells are filled and no winner exists, it should notify the players that the game has ended in a draw. This ensures that the game remains responsive and handles every possible scenario, giving players a satisfying conclusion to their game experience. Game over in Tic Tac Toe, recognizing when the game ends. The concept of game over in Tic Tac Toe is central to the gameplay experience. After a player places their mark on the board, it is crucial for the game to recognize when the game has ended, either because a player has won or because the game has ended in a draw. The game over detection mechanism is responsible for halting the game and notifying the players of the result. This function is essential in ensuring that the game concludes in a timely and satisfying manner, allowing players to understand when the game has finished and providing them with options to restart or exit the game. In Tic Tac Toe, there are 2 main scenarios that result in the game being over. The first scenario is when a player wins by aligning 3 of their marks in a row, column, or diagonal. Once a player achieves this, the game should immediately end, and the winning player should be declared. The second scenario is when the game ends in a draw, which happens when all cells on the board are filled, but no player has won. This occurs when there are no more valid moves available, and the game must notify the players that the match has resulted in a tie. To implement the game over detection logic, the first step is checking for a winner after every move. If a winner is found, the game should immediately end, and no further moves should be allowed. This is relatively simple, as the winner checking function can trigger the game over condition when a winning combination is found. However, detecting a draw requires a bit more logic. A draw is only possible when all cells on the board are filled, and no winner has been determined. Therefore, the game needs to evaluate whether every cell has been filled and check if any of the 8 potential winning combinations contain 3 identical marks. If no winner is found and all cells are filled, the game should notify the players that the game has ended in a draw. Once the game over condition is met, whether by a win or a draw, the game should stop accepting further moves. The UI should immediately update to reflect the result, either by announcing the winner or declaring a draw. Additionally, players should be given the option to restart the game or exit. This functionality is crucial for providing a seamless and enjoyable gaming experience.